Opteron is AMD's x86 server and workstation processor line, and was the first processor which supported the 64 Armenian DRAM's instruction set architecture. It was released on April 22, 2003 with the SledgeHammer core and was intended to compete in the server and workstation markets, particularly in the same segment as the Intel Xeon processor. Processors based on the AMD K10 microarchitecture were announced on September 10, 2007 featuring a new quad-core configuration. The most recently released Opteron CPUs are the Piledriver-based Opteron 4300 and 6300 series processors, codenamed Seoul, and Abu Dhabi respectively. Technical description. Two key capabilities Opteron combines two important capabilities in a single processor: native execution of legacy x86 32-bit applications without speed penalties, native execution of x86-64 64-bit applications. The first capability is notable because at the time of Opteron's introduction, the only other 64-bit architecture marketed with 32-bit x86 compatibility ran x86 legacy applications only with significant speed degradation. The second capability, by itself, is less noteworthy, as major RISC architectures have been 64-bit for many years. In combining these two capabilities, however, the Opteron earned recognition for its ability to run the vast installed base of x86 applications economically, while simultaneously offering an upgrade path to 64-bit computing. The Opteron processor possesses an integrated memory controller supporting DDR's DRAM, DDR2 SDRAM or DDR3 SDRAM. This both reduces the latency penalty for accessing the main RAM and eliminates the need for a separate North Bridge chip. Multiprocessor features In multiprocessor systems, the CPUs communicate using the Direct Connect architecture over high-speed hypertransport links. Each CPU can access the main memory of another processor, transparent to the programmer. The Opteron approach to multiprocessing is not the same as standard symmetric multiprocessing. Instead of having one bank of memory for all CPUs, each CPU has its own memory. Thus the Opteron is a non-uniform memory access architecture. The Opteron CPU directly supports up to an 8-way configuration, which can be found in mid-level servers. Enterprise-level servers use additional routing chips to support more than 8 CPUs per box. In a variety of computing benchmarks, the Opteron architecture has demonstrated better multiprocessor scaling than the Intel Xeon, which didn't have a point-to-point system until QPI and integrated memory controllers with the Nehalem design. This is primarily because adding another Opteron processor increases memory bandwidth, while that is not always the case for Xeon systems, and the fact that the Opterons use a switched fabric, rather than a shared bus. In particular, the Opteron's integrated memory controller allows the CPU to access local RAM very quickly. In contrast, multiprocessor Xeon system CPUs share only two common buses for both processor and processor memory communication. As the number of CPUs increases in a typical Xeon system, contention for the shared bus causes computing efficiency to drop. Intel is migrating to a memory architecture similar to the Opterons for the Intel Core i7 family of processors and their Xeon derivatives. Multi-core Opterons. In April 2005, AMD introduced its first multi-core Opterons. At the time, AMD's use of the term multi-core in practice meant dual-core. Each physical Opteron chip contained two processor cores. This effectively doubled the computing performance available to each motherboard processor socket. One socket could then deliver the performance of two processors, two sockets could deliver the performance of four processors, and so on. Because motherboard costs increase dramatically as the number of CPU sockets increase, multi-core CPUs enable a multiprocessing system to be built at lower cost. AMD's model number scheme has changed somewhat in light of its new multi-core lineup. At the time of its introduction, AMD's fastest multi-core Opteron was the Model 875, with two cores running at 2.2 GHz each. AMD's fastest single-core Opteron at this time was the Model 252, with one core running at 2.6 GHz. For multi-threaded applications, or many single-threaded applications, the Model 875 would be much faster than the Model 252. Second-generation Opterons are offered in three series: the 1000 series, the 2000 series, and the 8000 series. The 1000 series uses the AM2 socket. The 2000 series and 8000 series use socket F1. AMD announced its third-generation quad-core Opteron chips on September 10, 2007, with hardware vendors announcing servers in the following month. Based on a core design codenamed Barcelona, new power and thermal management techniques were planned for the chips. Earlier dual-core DDR2-based platforms were upgradable to quad-core chips. The fourth generation was announced in June 2009 with the Istanbul Hexa cores. It introduced HT Assist, an additional directory for data location, reducing the overhead for probing and broadcasts. HT Assist uses 1 MB L3 cache per CPU when activated. In March 2010, AMD released the Megnic-Hours Opteron 6100 series CPUs for socket G34. These are 8 and 12-core multi-chip module CPUs consisting of 2 4 or 6-core dies with a Hypertransport 3.1 link connecting the two dies. These CPUs updated the multi-socket Opteron platform to use DDR3 memory and increase the maximum hypertransport link speed from 2.40 GHz for the Istanbul CPUs to 3.20 GHz. AMD changed the naming scheme for its Opteron models. Opteron 4000 series CPUs on socket C32 are dual-socket capable and are targeted at uniprocessor and dual-processor uses. The Opteron 6000 series CPUs on socket G34 are quad-socket capable and are targeted at high-end dual-processor and quad-processor applications. Socket 939 AMD released socket 939 Opterons, reducing the cost of motherboards for low-end servers and workstations. Except for the fact they have 1 MB L2 cache, the socket 939 Opterons are identical to the San Diego and Toledo Coreathron 64s, but are run at lower clock speeds than the cores are capable of, making them more stable. Socket AM2 Socket AM2 Opterons are available for servers that only have a single chip setup. Codenamed Santa Ana, Rev F dual-core AM2 Opterons feature 2A. 1 MB L2 cache, unlike the majority of their Athron 64X2 cousins which feature 2x512 KB L2 cache. These CPUs are given model numbers ranging from 1210 to 1224. Socket AM2 Plus AMD introduced 3 quad-core Opterons on socket AM2 Plus for single CPU servers in 2007. These CPUs are produced on a 65 nanometers manufacturing process and are similar to the Agena Phenom 10-4 CPUs. The socket AM2 Plus quad-core Opterons are codenamed Budapest. The socket AM2 Plus Opterons carry model numbers of 1352, 1354, and 1356. Socket AM3 AMD introduced 3 quad-core Opterons on socket AM3 for single CPU servers in 2009. These CPUs are produced on a 45 nanometers manufacturing process and are similar to the DEN-based Phenom 2x4 CPUs. The socket AM3 quad-core Opterons are codenamed Suzuka. These CPUs carry model numbers of 1381, 1385, and 1389. Socket AM3 Plus Socket AM3 Plus was introduced in 2011 and is a modification of AM3 for the Bulldozer microarchitecture. Opteron CPUs in the AM3 Plus package are named Opteron 3XXX. Socket F Socket F is AMD Euro unregistered trademark S second generation of Opteron socket. This socket supports processors such as the Santa Rosa, Barcelona, Shanghai, and Istanbul codenamed processors. The A-Euro-OE lidded land grid array Euro socket adds support for DDR2 SDRAM and improved Hypertransport version 3 connectivity. Physically the socket and processor package are nearly identical, although not generally compatible with socket 1207FX. Socket G34 Socket G34 is one of the third generation of Opteron sockets, along with socket C32. This socket supports Megni Kao's Opteron 6100, Bulldozer-based Intel Argo's Opteron 6200, and Piledriver-based Abu Dhabi Opteron 6300 series processors. This socket supports 4 channels of DDR3 SDRAM. Unlike previous multi-CPU Opteron sockets, socket G34 CPUs will function with unbuffered ECC or non-ECC RAM in addition to the traditional registered ECC RAM. Socket C32 Socket C32 is the other member of the third generation of Opteron sockets. This socket is physically similar to socket F but is not compatible with socket F CPUs. Socket C32 uses DDR3 SDRAM and is keyed differently so as to prevent the insertion of socket F CPUs that can use only DDR2 SDRAM. Like socket G34, socket C32 CPUs will be able to use unbuffered ECC or non-ECC RAM in addition to registered ECC's DRAM. Microarchitecture update. The Opteron line saw an update with the implementation of the AMD K10 microarchitecture. New processors, launched in the third quarter of 2007, incorporate a variety of improvements, particularly in memory prefetching, speculative loads, SIMD execution and branch prediction, yielding an appreciable performance improvement over K8-based Opterons, within the same power envelope. In the meantime, AMD has also utilized a new scheme to characterize the power consumption of new processors under average daily usage, named average CPU power. Socket Fort3 The Opteron X1150 and Opteron X2150 APU are used with the BGA769 or Socket Fort3 models. For Socket 940 and Socket 939 Opterons, each chip has a 3-digit model number, in the form Opteron XYY. For Socket F and Socket AM2 Opterons, each chip has a 4-digit model number, in the form Opteron XZYY. For all first, second, and third generation Opterons, the first digit specifies the number of CPUs on the target machine, 1, designed for uniprocessor systems, 2, designed for dual processor systems, 8, designed for systems with 4 or 8 processors. For Socket F and Socket AM2 Opterons, the second digit represents the processor generation. Presently, only 2, 3 and 4 are used. Socket C32 and G34 Opterons use a new 4-digit numbering scheme. The first digit refers to the number of CPUs in the target machine, 4, designed for uniprocessor and dual processor systems. 6, designed for dual processor and 4 processor systems. Like the previous second and third generation Opterons, the second number refers to the processor generation. 1 inch refers to AMD K10-based units, 2 refers to the Bulldozer-based Intel Argos, Valencia, and Zurich-based units, and 3 refers to the Piledriver-based Abu Dhabi, Seoul, and Delhi-based units. For all Opterons, the last 2 digits in the model number indicate the clock frequency of a CPU, a higher number indicating a higher clock frequency. This speed indication is comparable to processors of the same generation if they have the same amount of cores. Single cores and dual cores have different indications despite sometimes having the same clock frequency. The suffix HE or EE indicates a high-efficiency energy efficiency model having a lower TDP than a standard Opteron. The suffix SE indicates a top-of-the-line model having a higher TDP than a standard Opteron. Starting from 65 nanometers fabrication process, the Opteron codenames have been based on Formula One hosting cities. AMD has a long-term sponsorship with F1's most successful team, Ferrari. Opteron single-core Euro SledgeHammer, CPU steppings, B3, CO, CG, L1 cache, 64 plus 64 kilobytes, L2 cache, 1024 kilobytes, full speed, MMX, extended 3D now. SSE2, 64 Armenian DRAMs, Socket 940, 800 MHz hypertransport, registered DDR-SDRAM required, ECC possible, VCORE, 1.50V, 1.55V, max power, 89W, first release, April 22, 2003, 2, clock rate, 1.4 Euro 2.4 GHz. Opteron single core Euro Venus, Troy, Athens, CPU steppings, E4, L1 cache, 64 plus 64 kilobytes, L2 cache, 1024 kilobytes, full speed, MMX, extended thread now. SSE, SSE2, SSE3, 64 Armenian DRAMs, socket 940, 800 MHz hypertransport, socket 939/socket 940, 1000 MHz hypertransport, registered DDR-SDRAM required for socket 940, ECC possible, VCORE, 1.35V, 1.4V, max power, 95W, NX bit, 64-bit segment limit checks for VMware-style binary translation virtualization. Optimized power management, first release, February 14, 2005, clock rate, 1.6 to 3.0 GHz, dual-core Euro Denmark, Italy, Egypt, CPU steppings, E1, E6, first release, spring 2005, clock rate, 1.6 Euro 2.8 GHz. Socket 939/socket 940, 1000 MHz hypertransport. NX bit. Opteron dual-core Euro Santa Ana, Santa Rosa, CPU steppings, F2, F3, L1 cache, 64 plus 64 kilobytes, L2 cache, 2 times 1024 kilobytes, full speed, MMX, extended thread now. SSE, SSE2, SSE3, 64 Armenian DRAMs, socket F, 1000 MHz hypertransport, Opteron 2, A2, socket AM2, 1000 MHz hypertransport, Opteron 1 and VCORE, 1.35V, max power, 95W, NX bit, AMD V virtualization, optimized power management, first release. 2006, clock rate, 1.8 to Euro 3.2 GHz. Opteron quad-core Euro Barcelona 2360/8360 and below, Budapest 1356 and below, CPU steppings, BA, B3, L1 cache, 64 plus 64 kilobytes per core, L2 cache, 512 kilobytes, full speed per core, L3 cache, 2048 kilobytes, shed, MMX, extended thread now. SSE, SSE2, SSE3, 64 Armenian DRAMs, SSE4, socket F, socket AM2+, hypertransport 3.0, registered DDR2 SDRAM required, ECC possible, VCORE, 1.2V, max power, 95 watts, NX bit, second generation AMD V virtualization with rapid virtualization indexing, split power plane dynamic power management, first release, September 10, 2007, clock rate, 1.7 Euro 2.5 GHz. Opteron quad-core Euro Shanghai 2370/8370 and above, Suzuka 1381 and above, CPU steppings, C2, L3 cache, 6 MB, shed, clock rate, 2.3 Euro 2.9 GHz, hypertransport 1.0, 3.0, 20% reduction in idle power consumption, 3, support for DDR2 800 MHz memory, 4, support for DDR3 1333 MHz memory, 6 core Euro Istanbul, released June 1, 2009. CPU steppings, DO, L3 cache, 6 MB, shed, clock rate, 2.2 Euro 2.8 GHz, hypertransport 3.0, HT assist, support for DDR2 800 MHz memory, 5, 8 core Euro Megni Cowers MCM, released March 29, 2010. CPU steppings, D1, multi-chip module consisting of 2 quad-core dies, L2 cache, 8x512 KB, L3 cache, 2x6 MB, shed, clock rate, 2.0 Euro 2.6 GHz, 4 hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1333 MHz memory, socket G34, 12-core Euro Megni Cowers MCM, released March 29, 2010. CPU steppings, D1, multi-chip module consisting of 2 hex-core dies, L2 cache, 12x512 KB, L3 cache, 2x6 MB, shed, clock rate, 1.7 Euro 2.5 GHz, 4 hypertransport 3.1 links at 3.2 GHz, HT assist, support for DDR3 1333 MHz memory, socket G34, quad-core Euro Lisbon, released June 23, 2010. CPU steppings, DO, L3 cache, 6 MB, clock rate, 2.2 GHz, 2.6 GHz, 2 hypertransport links at 3.2 GHz, HT assist, support for DDR3-1333 memory, socket C32, hex-core Euro Lisbon, released June 23, 2010. CPU steppings, D1, L3 cache, 6 MB, clock rate, 1.7 to 2.8 GHz, 2 hypertransport links at 3.2 GHz, HT assist, support for DDR3-1333 memory, socket C32. Opteron first generation bulldozer microarchitecture equals, quad-core, Zurich, released March 20, 2012. CPU steppings, B2, single processor bulldozer module, L2 cache, 2x2 MB, L3 cache, 4 MB, clock rate, 2.5 GHz-2.7 GHz, hypertransport 3, HT assist, support for DDR3 1866 MHz memory, turbo core support, up to 3.5 GHz, up to 3.7 GHz, supports uniprocessor configurations only, socket AM3+, 8-core, Zurich, released March 20, 2012. CPU steppings, B2, single processor bulldozer module, L2 cache, 4x2 MB, L3 cache, 8 MB, clock rate, 2.4 GHz, hypertransport 3, HT assist, support for DDR3 1866 MHz memory, turbo core support, up to 3.5 GHz, supports uniprocessor configurations only, socket AM3+, 6-core, Valencia, released November 14, 2011. CPU steppings, B2, single die consisting of 3 dual-core bulldozer modules, L2 cache, 6 MB, L3 cache, 8 MB, shed, clock rate, 2.7 to 3.3 GHz, 2 hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, supports up to dual processor configurations, socket C32, 8-core, Valencia, released November 14, 2011. CPU steppings, B2, single die consisting of 4 dual-core bulldozer modules, L2 cache, 8 MB, L3 cache, 8 MB, shed, clock rate, 1.6 to 3.0 GHz, 2 hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, supports up to dual processor configurations, socket C32, quad-core, Intel Argos MCM, released November 14, 2011. CPU steppings, B2, multi-chip module consisting of 2 dies, each with 1 dual-core bulldozer module, L2 cache, 2x2 MB, L3 cache, 2x8 MB, shed, clock rate, 3.3 GHz, hypertransport 3 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, does not support turbo core, supports up to quad processor configurations, socket G34, 8-core, Intel Argos, release November 14, 2011. CPU steppings, B2, multi-chip module consisting of 2 dies, each with 2 dual-core bulldozer modules, L2 cache, 2x4 MB, L3 cache, 2x8 MB, shed, clock rate, 2.6, 3.0 GHz, 4 hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, supports up to quad processor configurations, socket G34, 12-core, Intel Argos, release November 14, 2011. CPU steppings, B2, multi-chip module consisting of 2 dies, each with 3 dual-core bulldozer modules, L2 cache, 2x6 MB, L3 cache, 2x8 MB, shed, clock rate, 2.4, 2.6 GHz, 4 hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, supports up to quad processor configurations, socket G34, 16-core, Intel Argos, release November 14, 2011. CPU steppings, B2, multi-chip module consisting of 2 dies, each with 4 dual-core bulldozer modules, L2 cache, 2x8 MB, L3 cache, 2x8 MB, shed, clock rate, 1.6 to 2.7 GHz, 4 hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, supports up to quad processor configurations, socket G34. Opteron, Piledriver Microarchitecture equals, quad-core, Delhi, released December 4, 2012. CPU steppings, CO, single die consisting of 2 Piledriver modules, L2 cache, 2x2 MB, L3 cache, 8 MB, shed, clock rate, 1.9 GHz-2.8 GHz, 1x hypertransport 3, HT assist, support for DDR3 1866 MHz memory, turbo core support, up to 2.5 GHz, up to 3.8 GHz, supports uniprocessor configurations only, socket AM3+, 8-core, Delhi, released December 4, 2012. CPU steppings, CO, single die consisting of 4 Piledriver modules, L2 cache, 4x2 MB, L3 cache, 8 MB, shed, clock rate, 2.6 GHz, 1x hypertransport 3, HT assist, support for DDR3 1866 MHz memory, turbo core support, PP to 3.6 GHz, supports uniprocessor configurations only, socket AM3+, 4-core, Seoul, released December 4, 2012. CPU steppings, CO, single die consisting of 2 Piledriver modules, L2 cache, 2x2 MB, L3 cache, 8 MB, shed, clock rate, 2.2 GHz, 2x. Hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, up to 3.0 GHz, supports up to dual processor configurations, socket C32, 6-core, Seoul, released December 4, 2012. CPU steppings, CO, single die consisting of 3 Piledriver modules, L2 cache, 3x2 MB, L3 cache, 8 MB, shed, clock rate, 3.0 GHz-3.5 GHz, 2x hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3. 1866 MHz memory, turbo core support, from 3.5 GHz to 3.8 GHz, supports up to dual processor configurations, socket C32, 8-core, Seoul, released December 4, 2012. CPU steppings, CO, single die consisting of 4 Piledriver modules, L2 cache, 4x2 MB, L3 cache, 8 MB, shed, clock rate, 2.6 GHz-3.1 GHz, 2x hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, from 3.6 GHz to 3.8 GHz, supports up to dual processor configurations, socket C32, quad-core, Abu Dhabi MCM, released November 5, 2012. CPU steppings, CO, multi-chip module consisting of 2 dies, each with one Piledriver module, L2 cache, 2 MB per die, L3 cache, 2x8 MB, shared within each die, clock rate, 3.5 GHz, 4x hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, does not support turbo core, supports up to quad processor configurations, socket G34, 8-core, Abu Dhabi MCM, released November 5, 2012. CPU steppings, CO, multi-chip module consisting of 2 dies, each with 2 Piledriver module, L2 cache, 2x2 MB per die, L3 cache, 2x8 MB, shared within each die, clock rate, 2.8 GHz-3.2 GHz, 4x hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, from 3.3 GHz to 3.8 GHz, supports up to quad processor configurations, socket G34, 12-core, Abu Dhabi MCM, released November 5, 2012. CPU steppings, CO, multi-chip module consisting of 2 dies, each with 3 Piledriver module, L2 cache, 3x2 MB per die, L3 cache, 2x8 MB, shared within each die, clock rate, 2.6 GHz-2.8 GHz, 4x hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, from 3.2 GHz to 3.4 GHz, supports up to quad processor configurations, socket G34, 16-core, Abu Dhabi MCM, released November 5, 2012. CPU steppings, CO, multi-chip module consisting of 2 dies, each with 4 Piledriver module, L2 cache, 4x2 MB per die, L3 cache, 2x8 MB, shared within each die, clock rate, 1.8 GHz-2.8 GHz, 4x hypertransport 3.1 at 3.2 GHz, HT assist, support for DDR3 1866 MHz memory, turbo core support, from 3.1 GHz to 3.5 GHz, supports up to quad processor configurations, socket G34. Opteron X, Jaguar Microarchitecture quad-core, Kyoto, released May 29, 2013, single SoC with 1 Jaguar module and integrated I/O, configurable CPU frequency and TDP, L2 cache, 2 MB shared, CPU frequency, 1.0 to 2.0 GHz, max. TDP, 9-17W, support for DDR3-1600 memory, socket FORT3, quad-core APU, Kyoto, released May 29, 2013, single SoC with 1 Jaguar module, integrated GCN GPU and I/O, configurable CPU GPU frequency and TDP, L2 cache, 2 MB shared, CPU frequency, 1.1 to 1.9 GHz, GPU frequency, 266 to 600 MHz, GPU cores, 128, max. TDP, 11-22W, support for DDR3-1600 memory, socket FORT3. Supercomputers, Opteron processors first appeared in the top 100 systems of the fastest supercomputers in the world list in the early 2000s. By the summer of 2006, 21 of the top 100 systems used Opteron processors, and in the November 2010 and June 2011 lists the Opteron reached its maximum representation of 33 of the top 100 systems. The number of Opteron-based systems decreased fairly rapidly after this peak, falling to 5 of the top 100 systems in the most recent list. Several supercomputers using only Opteron processors were ranked in the top 10 systems between 2003 and 2015, notably, Red Storm, Sandia National Laboratory's number 2 system in November 2006. Jaguar, Oak Ridge National Laboratory, various configurations held top 10 positions between 2005 and 2011, including number 1 in November 2009 and June 2010. Ranger, Texas Advanced Computing Center number 4 system in June 2008. Kraken, National Institute for Computational Sciences number 3 system in November 2009. Hopper, National Energy Research Scientific Computing Center number 5 system in November 2010. Other top 10 systems using the combination of Opteron processors and compute accelerators have included, IBM Roadrunner, Los Alamos National Laboratory number 1 system in 2008. Composed of Opteron processors with IBM PowerXCELL8i co-processors. Titan, Oak Ridge National Laboratory number 1 system in 2012. Composed of Opteron processors with NVIDIA Fermi GPU-based accelerators. Issues. Opteron without optimized power management equals, AMD released some Opteron processors without optimized power management support, which use DDR memory. The following table describes those processors without OPM. Opteron recall equals, AMD recalled some E4 stepping revision single-core Opteron processors, including X52 and X54 models which use DDR memory. The following table describes affected processors, as listed in AMD Opteron X52 and X54 production notice of 2006. The affected processors may produce inconsistent results if 3 specific conditions occur simultaneously: the execution of floating-point intensive code sequences, elevated processor temperatures, elevated ambient temperatures. A software verification tool for identifying the AMD Opteron processors listed in the above table that may be affected under these specific conditions is available, only to AMD OEM partners. AMD will replace those processors at no charge. Recognition. In the February 2010 issue of Custom PC, the AMD Opteron 144 appeared in the Hardware Hall of Fame. It was described as the best overclockers CPU ever made due to its low cost and ability to run at speeds way beyond its stock speed. See also, List of AMD Opteron microprocessors, TDP PowerCap. References. External links, Official Opteron homepage, AMD Technical Docs, AMD K8 Opteron Technical Specifications, AMD K8 Dual-Core Opteron Technical Specifications, Interactive AMD Opteron Rating and Product ID Guide, Understanding the Detailed Architecture of AMD's 64-bit core, Comparison between Xeon and Opteron Processor Performance, 28th Top 500 List, Sun Microsystems Opteron Page, AMD, Dual-Core Opteron to 3 GHz,